Hi guys. On the last video I got cut off in the middle of the last part of explaining this problem, so I just wanted to come back and hit this a little bit more. Finding the cosine inverse of negative square root of 3 over 2. So what we started going over is like, let's look at this as a positive square root of 3 over 2 and figure out what the cosine of positive square root of 3 over 2 is, and then we'll switch to the negative. So remember what we're finding is we're finding an angle. Cosine inverse means we're finding an angle, or arc cosine is another way to say that. It means the same thing. So you could also have written this as arc cosine of negative square root of 3 over 2. So for just a minute, let's ignore the negative, and let's figure out the arc cosine and the sine cosine inverse mean we're going to find an angle that gives us a ratio of square root of 3 over 2. And that's for the adjacent over hypotenuse, which is what the ratio of the cosine is. So we're finding an angle when we're finding sine inverse, cosine inverse, tangent inverse, or arc cosine, arc sine, arc tangent. All of those mean find an angle. And so if I just use my special triangles, which I know you have memorized, the square root of 3 over 2 is from one of our special triangles, and it's the 30, 60, 90. Or in radians, pi over 6, pi over 3, pi over 2. And the ratio of sides is, if this side is 1, the hypotenuse is twice that, and the side opposite of the pi over 3, or 60 degrees, is square root of 3. And so, remember, cosine is the side adjacent over the hypotenuse, which angle gives us a side adjacent of square root of 3, and hypotenuse of 2. And that would be this angle right here, pi over 6. So if it was a positive, if we were finding cosine inverse of positive square root of 3 over 2, it's equal to pi over 6. It's that angle that would give us that ratio. But we're finding where it's equal to negative square root of 3 over 2. Okay, so I'm going to back up to what we did a couple days ago with looking at the cosine graph, which is this blue graph here on the left. And remember, we had to restrict the domain so that our inverse would also be a function. Otherwise, the cosine curve isn't one-to-one. It doesn't pass the horizontal line test. So if we graph the inverse, we'd have something going up the y-axis, and we would not have a function. It wouldn't pass the vertical line test. So we restrict the domain to values of, it's the radian values of between 0 and pi. So this is going to be a restricted domain from 0 to pi. Our range is still going from negative 1 to 1. So then what we did is we graphed the inverse, and recall that the inverse is going to interchange all these xy ordered pairs. So this point right here is at 0, 1. So notice that I switched how I labeled the axes. The y-axis is now in radians, and the x-axis is in terms of between negative 1 and 1. And so that's what's going to happen. Our domain and our range, because the inverse interchanges all x's and all y's, the whole entire domain and range interchange as well. So I'm going to have a domain that goes from negative 1 to 1, which is why I put negative 1 and 1 on my x-axis instead of my y. And my range is going to go from 0 to pi. So then we graphed this. We interchanged our ordered pairs. So we have 0, 1 here. So 1, 0, interchange it. That will be 1, 0 is on the inverse graph. This point right here is pi over 2, 0. So 0, pi over 2 is on my inverse. And then this one right here, and I'm just picking some that are easy to find, at pi, negative 1, that's on the regular cosine curve in our restricted domain. So reverse that, negative 1, or interchange it, negative 1, pi will be on the inverse. So the inverse graph looks like that, and it stops, because if I continued on in these directions, I would end up with a graph that is not a function. So this is the inverse function for cosine inverse, its function graph. So what your calculator is going to do is your calculator can only give you answers that are in this inverse function. So if I were to enter into the calculator cosine inverse of negative square root of 3 over 2, I will get the same result as what I'm going to show you in just a minute. So my answer when I am finding this has to be, my radian measure has to be in between, it's going to be this output here between 0 and pi. Now, so that's corresponding with the red graph here. And you can also think of it as a circle graph. 0 to pi goes from here to here. And remember, the cosine is positive here. The cosine is negative in quadrant 2. So if we're talking about a negative square root of 3 over 2, it's going to be a multiple. It's going to be the same answer, but it's going to be a multiple of 5 pi over 6. Not the same answer. It's going to be a multiple of pi over 6. And think about what angle, after it's been simplified, in quadrant 2 is going to be a multiple of pi over 6, and that angle would be, hopefully you know it, that angle would be 5 pi over 6. So 5 pi over 6 would give us an output, if you think of it in like a right triangle here, using this little reference angle of pi over 6, this would be the ratio of 1, the hypotenuse is 2, or the radius is 2, and this side would be negative square root of 3. And since the cosine is the side adjacent, which is negative square root of 3 over 2, that would give us, that angle, 5 pi over 6, would give us a ratio of sides adjacent to hypotenuse of negative square root of 3 over 2. So this answer here is going to be 5 pi over 6. Okay, so your answer for cosine inverse oh, you know what, before I do that, what I wanted to do is just throw this in a calculator and show you that it's the same thing as 5 pi over 6. Alright, first thing I want to do to check this is I want to make sure I'm in radian mode, and my calculator is not, so I'm going to switch it to radian mode. And then I'm going to find the cosine inverse of negative square root of 3 over 2. So I have to hit second cosine negative square root of 3 divided by 2, and I get 2.617, you can see the decimal there, which should be equivalent to the answer we got, which was 5 pi divided by 6, and it is. So, alright, so that was just to show you that little piece. Okay, so back to our inverse trig function. So cosine inverse of an angle theta, sine inverse of angle theta, oops, no, I'm finding an angle, I'm sorry, this is not correct, of cosine inverse of the output, which would be your side adjacent to hypotenuse, so the ratio would be here. Sine is opposite over hypotenuse, or you'd have a ratio, a number in there like 1/2, or it doesn't have to be from the special triangles, it could be a random decimal too. And then tangent inverse means when you're finding any of these, we're finding an angle. So this would equal, we're trying to figure out what angle would give us that. So we're finding an angle when we're finding these inverses. And I just want to write down what the restricted answer will be. So for the cosine, your angle theta is going to be between 0 and pi. And for both sine and tangent, the angle is going to be between negative pi over 2 and pi over 2. And for sine, those values are included as part of the answer. And for tangent, they are not included. But it's the same endpoints, but sine is included and tangent is not included. So for example, if you were going to find sine inverse of, let's say, 1, you're looking for what angle gives you the sine value of 1. And the answer would be pi over 2, because what you're finding, sine of what angle equals 1, and it's the sine of pi over 2 that equals 1. Remember the graph of sine, which looks like this. This and the values on the x-axis here, this is 0, and this is pi over 2, this is pi, this is at 3 pi over 2, and back to 2 pi. So at pi over 2, your sine ratio is 1, so that means the sine inverse of 1 is pi over 2. And so if I was finding sine inverse of negative 1, it's actually almost easier. It's going to just be the negative, it's going to be the same angle but negative. So for both tangent and sine, it's just going to be if you can find it in quadrant 1, then it's just the opposite. Put a negative in front of it if this ratio is a negative. And that's that. All right. Try to do assignment 4.7, and we can continue with it tomorrow.